Welcome to The Explainer. Today, we are going to tackle one of the biggest, most talked about pieces of tech out there, the large language model. You've definitely used them or at least seen them in action. Tools like ChatGPT, right? They can write poetry, whip up an email for you, they can even write code. They just seem to get what you're saying and can write back almost like a person. So you type something in, and bam, this perfectly written answer just pops out. But what is actually happening in there? What's going on behind the curtain? Well, today we're going to pull that curtain back and take a good look at the engine without any of the hype. Okay, let's dive right in. We're going to get into the real guts of this machine, starting from the ground up, so we're all on the same page. All right, first things first. Artificial intelligence. At its core, the idea is actually pretty simple. We're just talking about creating behaviors that seem intelligent. If a machine does something that you or I would call smart, boom, we label it AI. But here's the key. It is not magic. And because it's not magic, it means we can actually explain it. So, how do we get that intelligent-seeming behavior? Well, that's where machine learning comes into play. See, instead of some poor programmer trying to write a bazillion if-then rules for language, which, let's be real, would be impossible, we do something way smarter. We feed the machine a mind-boggling amount of data, like a huge chunk of the internet, and we let it figure out the patterns and build its own little model of how language works. And the machine doing all this heavy lifting? That's typically a neural network. Now for a second, just forget the whole it works like a brain analogy. I want you to picture a really, really complex electrical circuit instead. Imagine a self-driving car. You've got inputs from sensors, right? And outputs, like steering the wheel. Well, training the network is like fine-tuning billions of tiny little knobs and switches in that circuit until the electricity flows just right, making the car act the way a human driver would. So how does that circuit idea apply to language? Well, think of a language model as like a giant magical typewriter. Its only job, its entire purpose, is to guess which word comes next. And you can imagine it has a little metal striker arm for every single word that exists. Based on the words you've already typed, it sends a powerful jolt of electricity to just one of those arms, and whack, it hits the page. That's your next word. Now, the engine that runs most of these modern LLMs is something called a transformer. And it's basically got this cool three-step dance. First, an encoder takes every word and turns it into a list of numbers, like a unique numerical fingerprint. Then comes the secret sauce, self-attention. This is where the magic really happens. The model looks at the whole sentence and figures out which words are important to each other, connecting queen to crown. It then mixes their numerical fingerprints together to create a richer meaning. Finally, a decoder takes that new, context-rich code and makes a much, much smarter guess about what the next word should be. So, there you have it, a super complex circuit that's amazing at guessing the next word. But is that the whole story? Oh, not even close. This is where things start to get really weird. And this is where we hit the big central paradox of it all. We built these things. We designed the circuits. But they've become so mind-bogglingly complex that, honestly, we don't fully get how they work. In fact, top researchers have started studying the biggest models like there's some strange natural phenomenon, like observing a weird new weather pattern and just trying to figure out the rules. And believe me, that's not an exaggeration. As computer scientist Boaz Barak puts it, it's like we're in the early days of physics. We're seeing all these wild experimental results, but we just don't have the theories to explain them yet. And some of those results are truly bizarre. So let me give you an example. There's this thing researchers have called grokking. They had a model training on a simple math task, and it was failing. Just failing for ages. They accidentally left it running for days, way past the point they would have normally just shut it down. And when they came back, the model had suddenly, out of nowhere, completely mastered the task. It was like a switch just flipped on inside of it. And this really gets at a super important difference. For most of its training, the model was just memorizing answers, kind of like a student cramming for a test. It could spit back what it saw, but that's it. But then it grokked the problem. It made this incredible leap from just memorizing to actually forming a general rule. It started to understand the underlying pattern. And the crazy part? We have no idea why or when that switch flips. Okay, if that wasn't weird enough for you, get ready for something called double descent. For decades, the rule in statistics was simple. You make a model bigger, it gets better. up to a point. Then it gets too good at the specific data it trained on. That's called overfitting, and its performance on new stuff gets worse. But with these new, massive models, something totally wild happens. Their performance gets better, then it gets worse, just like the old rules said, but then it suddenly reverses course and starts getting better again, defying everything we thought we knew. Now, these strange behaviors aren't just for academic papers. They have very real consequences for all of us who use these tools, and it leads to a really interesting paradox. You see, those raw language models we talked about, they can be a little weird and unhelpful, so developers have to shape them up. They use a technique called reinforcement learning with human feedback, or RLHF, which is just a fancy way of saying that real people sit down and rate the model's answers. Thumbs up, thumbs down. And this trains the model to be more conversational and better at following your instructions. And this process absolutely makes them feel a whole lot more helpful, right? But does it actually make them more reliable? Well, a recent study in the journal Nature uncovered a pretty critical trade-off happening just beneath the surface. And this comparison lays it out perfectly. The raw, early models, they were often kind of evasive. If they didn't know something, they might just give a weird answer or say, I don't know. Their main type of error was avoidance. But these new, shaped-up models have been trained to always give you a helpful-sounding answer. So now, their main error type is just pure incorrectness. They'll just make something up. And you can see it right here in the data. Look at what happens. That shaping process does a great job of getting rid of those I don't know answers. But look at the trade-off. The number of flat-out incorrect answers skyrockets. They've literally been trained to swap one kind of error for another. So here's the bottom line, the thing you really need to remember. In the process of making these AI models more helpful, we've accidentally trained them to be much more confidently wrong. It makes them feel more powerful, sure, but it puts a much, much bigger burden on you, the user, to double-check everything they say. Okay, so after all that, what does this actually mean for you when you sit down to use one of these things? Let's put together a quick and practical guide to navigating the power and the pitfalls of these incredible tools. So where do these things really shine? Well, they're amazing at things like generating creative text, summarizing a long document, or translating languages. Basically, anytime you ask an LLM to do something clever and it works, it's because it's seen billions of examples of that exact kind of pattern online, and it is an absolute master at recreating it for you. But you have to remember the pitfalls. They hallucinate, which is a nice way of saying they just make stuff up. And this is the big one. They have zero concept of truth. They are word guessers, not fact checkers. A single bad word guess can send an entire answer spiraling into nonsense, which is why you have to verify anything important that comes out of them. So that brings us to the final question, and really the whole point. What do we do with a tool that is, at the same time, this incredible creative partner and a completely unreliable narrator? Well, understanding that contradiction, that dual nature, is the absolute key to using these things well. It's how we tap into their amazing potential while always staying aware of their very real and very fascinating limits.